Hello, my name is Victoria Klonkowski.
Hello, my name is Omi Johnson.
Hi, I'm Shannon Haley.
Today, we'll be presenting on this Colobus Curio Cabinet proposal paper.
This project began in an animal-computer interaction course at Northeastern University, where we explored how technology can enhance animal well-being and agency. It was developed through Rebecca Kleinberger's Interact Animal Lab. As part of the course, we partnered with Zoo New England's Stone Zoo to design and prototype enrichment for their Colobus guereza family.
In this troop, shown from left to right, we have Tika, the mother and her new baby, Isoke, the father, Faraha and Kenya, their daughters, and George, their 1-year-old son. And in the bottom right, we have the troop all together in the indoor enclosure. When the zookeepers at Stone Zoo in Stoneham, Mass. Approached us, they highlighted this troop from among their animals that could benefit from additional enrichment to round out their programming. This species is generally viewed as slower moving and less food motivated, and that it can be harder to generate interest and engagement and enrichment tools with them.
The troop's indoor enclosure already has many elevated surfaces, and because the colobus are as a primarily arboreal species, this provides ample opportunity for them to engage in their behaviors, including jumping, climbing, and swinging. So we wanted to provide an enrichment forum that promotes their other typical behaviors.
To explore other enrichment categories, we looked into mirrors. Handheld mirrors have documented success with the colobus monkeys at Stone Zoo, who use and frequently engage with a small portable mirror as part of their regular enrichment rotation. There's a significant amount of research covering use of mirrors with primates. However, most of this research centers around cognitive behavioral testing, enrichment in low engagement environments like lab testing, and mirrors fixed to the outside of enclosures. Generally, this research has found that apes and monkeys show interest in reflective surfaces, using mirrors to observe their environment and monitor conspecifics without engaging in direct eye contact, which is often perceived as threatening. A core finding here is that mirrors elicit species-typical behavior, even in species not known to exhibit mirror self-recognition. In contrast to these approaches, we expected that working from an animal-centered standpoint in iterative collaboration with the zookeepers would result in a better combination of enrichment categories involved, a better outcome for the colobus troop themselves, and a more realistic contribution to the area of research. Following ACI best practices for enrichment, and in collaboration with the zoo staff, we followed a behavior-based approach where we started from the animals' ethograms used by the zoo, then noted which behaviors the zookeepers identified we wanted to observe more. Our design goals included promoting exploration and cognitive engagement behaviors, a design that is not overly simple in order to promote long-term interest and engagement. Many devices used have only one function, which animals quickly get bored with. Ensuring ease of use with a lightweight and self-contained design, meeting the zoo's strict safety requirements, including material quality, natural-looking solutions to support visitor engagement and messaging, and prioritizing agency and consent in interactions.
For the design process, we followed an iterative design process in close collaboration with the professional staff at Stone Zoo. We worked from low fidelity to high fidelity prototypes through a multi-step process and used increasingly detailed presentation formats to collect feedback. In the initial brainstorming stage, we brainstormed rapid-fire sketches centered around our design requirements. We presented the sketches to zoo staff, of which some sketches, like the Hidden Vines mirror, were of interest, but each presented design concerns. We then constructed a low-fidelity cardboard prototype which integrated the best aspects of several brainstorm sketches. The new proposed design was a cabinet with covers obscuring modular openings, a box, a mirror, or a screen. We provided photos of this prototype to zoo staff, who approved the idea and gave practical feedback on implementation. Next, to test preferred materials and anticipate engineering challenges, we built a higher fidelity test prototype of isolated design components using intended final materials. For example, mounting various leaf cover ideas on PVC backboard. We recorded short videos of these prototypes to the zoo staff with holistic, directed questions around the entire prototype. As we finalized a majority of the design, we then built a detailed 3D model of the prototype within AutoCAD Fusion. We provided the staff an interactive link so they could manipulate the models themselves and provide detailed feedback on intricacies like module attachment.
The final design of the Colobus Curio Cabinet would be a modular wall-mounted enrichment system to encourage exploration through tactile and visual interaction. The cabinet has 5 openings, which can fit interchangeable modules, which helps to keep the experience novel between sessions. Proposed modules focus on mirror and screen interactions, here depicted as a flat mirror, concave mirror, small dangling mirror, and a digital screen. New modules could be theoretically constructed to encourage new interaction pathways. Each module is hidden behind a natural-looking module cover, here depicted as a fire hose leaf or rope vines. The Colobus would move these covers aside to reveal the mirrors underneath. Inside the cabinet, sensors and cameras would track when and how the Colobus interact with each module. All electronics are fully sealed and tamper-proof to ensure both safety and durability in their enclosure.
We propose an evaluation protocol to assess the cabinet through recorded observation sessions. First, a pilot test would deploy a dummy prototype in the enclosure with each of our proposed module covers. We would outfit the final prototype with the 2 most used covers from this trial, supporting animal and agency and enrichment design. The study would then be conducted by recording a 1-week baseline session and a 2-week deployment session. The cabinet would be installed on observation days, and module placements would be varied day by day. Objectives would be to assess overall use, assess interactions with individual modules and covers, and assess whether Colobus engaged positively with the device. Frequency measures, duration measures, and qualitative measures, such as Colobus expressions, would be collected through embedded sensors and external cameras. We would also present short surveys to staff to identify Colobus individuals during sessions. Data could be analyzed using repeated measures ANOVA to assess changes in engagement within and between sessions.
The Colobus Curio Cabinet could allow for easy variation in interaction pathways without significant time investment or expense for zoo staff, enhancing the practical application of potential research findings. The multi-opening system and module covers would allow for consensual mirror use and introduce a layer of complexity and integration which could improve long-term novelty and offer new opportunities to evaluate efficacy. For research, analysis could extract insights about interactive components and compare digital and analog mirrors.
Our detailed design pipeline reveals important insight into effective collaboration strategies with zoo personnel for enrichment design. The ability to iterate on 4 animal-facing design dimensions, structure, covers, module, and tech, introduced a level of complexity and collaboration that is rare among comparable zoo enrichment studies. Our design goals were defined by zoo-approved behavior goals and mirror-specific constraints. Maintaining this list of goals kept design iteration tightly focused and provided a framework for discussion, as well as facilitated the collapse of brainstorming sketches into a single design. During iteration, we found that iterating in parallel across all aspects of the design, rather than focusing on each component one by one, was the most effective strategy to both maintain continuity for zoo staff and catch possible issues around interaction between aspects early on. While communicating with the zoo staff, we gradually increased presentation complexity over time in tandem with familiarity with the design. Paper sketches to photos, photos to videos, and videos to 3D models. By contrast, questions remained well-structured and focused on specific concerns to most effectively use the staff's time.
In conclusion, the Colobus Curio Cabinet proposal offers a novel approach to animal enrichment in the field of animal-computer interaction. It prioritizes animal agency, uses modularity to sustain long-term engagement, and demonstrates effective collaborative design strategies. By shifting from traditional mirror testing to experience-based exploration, we're opening new research directions while creating practical enrichment that could benefit both animals and zoos. Finally, our detailed design documentation offers insight on best practices during collaborative zoo enrichment design. Thank you for attending our presentation. We thank all of our collaborators, including the incredible team at Stone Zoo, Interact Animal Lab, Northeastern University, Johnson Woodworks, and the Stone Zoo Colobus Troop, and look forward to future opportunities for collaboration.